Hi, and welcome to this lesson on object mutability and immutability. So let's consider again an object in memory. So remember, an object is basically something that has a type and it also has some internal data. It has state and it's located at some memory address. So changing the data inside the object is called modifying the internal state of the object. So let's take a look at an example of that. Let's say we have this variable myAccount, and myAccount references some object in memory at some memory address. Let's say memory address 1000. And let's say that the data type of this object is bank account, and bank account has two instance properties. It has an account number and a balance. So right now the account number is 12345, the balance is 150. Now suppose that we modify the balance. So we've changed the balance, we've deposited some money, and now the balance is 500. So you'll notice that the internal state, the data, has changed, but the memory address has not changed, right? So unlike when we were dealing with integers where we had my var was pointing to 10, and then when we said my var equals 15, it changed the reference to a new integer object containing 15. Here, we're actually modifying the internal state of the same object. All right, so the data has changed, but the memory address has not changed. And we say that the object was mutated, which is really just a fancy way of saying that the internal state of the object changed. Okay, so there's a little bit of a difference. So now we can get to a definition. An object whose internal state can be changed is called mutable. But an object whose internal state cannot be changed is called immutable. Right? So these are just two definitions that you should remember and keep in mind, because that is important. As we create objects throughout the lifetime of our programs, we kind of need to know, are those mutable objects or those immutable objects? It can make a difference. So let's look at some examples in Python, and let's start with immutable objects. Well, all numbers in Python are immutable. So ints, floats, booleans, complex numbers, these are all immutable objects. In other words, they get created in memory at some memory address, but we can never change the internal data, the internal value of that number. And we saw that in the last lesson when we were creating my var equals 10 and then we said my var equals 15. We saw that we were actually changing the reference from one integer 10 to another integer with a value of 15. We never modified the internal state that was contained inside that integer. And that's in part because integers are immutable. Strings are also immutable. Once you create a string, you can never modify that string. You can assign a new string to your variable, but you cannot change the internal state of that string. Tuples are also immutable, and we'll look at that in a few seconds. But tuples, if you remember, are created with round brackets. They're essentially a container type of object that contains elements. Now the tuple is immutable in the sense that you cannot add or remove or replace elements in that list or in that container. Frozen sets, which we'll look at in a lot more detail in this course, are also immutable type of objects. And of course, user-defined classes can also be immutable. If you define your own class and you don't allow for any way of modifying the internal state of that object, you've created an immutable object. Now what about mutable types? Well, lists in Python are mutable. Lists, if you remember, are created with square brackets, and they're also a container type, just like a tuple is a container type. The difference between the list and the tuple is that in lists you can add, remove, or replace elements in that list. So the list is a mutable object. Sets are also mutable, and we'll again look into sets in a lot of detail in this course. but sets are mutable, as are dictionaries. And sets and dictionaries are actually very related. But dictionaries are also mutable. You can add keys, you can remove keys, you can modify the value assigned to a key inside a dictionary, and so on. And again, we'll look into dictionaries in a lot of detail in this course. And of course, your own user-defined classes can be mutable. You can write a class and you can allow people to change the value of, variables inside your class. You can allow state changes to happen, in which case you have a mutable object. All right, but a word of warning about mutability and immutability. And it's a fine point, but let's take a look at a tuple. So let's say t equals 1, 2, 3. So this is a tuple. Now remember, the tuple is immutable, right? So you cannot add or remove or replace elements in that list. Now furthermore, in this case, the tuple itself is immutable, but all the elements inside the tuple are integers, and so they are also immutable. But now consider this. Let's say that we create two variables, a and b, both lists. Now, lists we know are mutable. We can add elements, remove elements, replace elements in lists. So those are a mutable type of objects. Now let's create a tuple that consists of two elements, a and b. In other words, t is a tuple where the first element is a list containing 1 and 2, and the second element is also a list containing 3 and 4. Now, we've got to be a little careful here, because we can now add elements to A and B, because A and B are lists and are mutable. So now, once we've executed those two lines of code, our tuple looks like this, right? The first element changed from 1, 2 to 1, 2, 3, and the second element changed from 3, 4 to 3, 4, 5. So you'll notice that, yes, the tuple is immutable. We did not change the elements that are referenced in these two positions, right? This 1, 2 and 1, 2, 3 are still the same object reference. They're still the same memory address. Same thing with the second element. We cannot add elements to T. We cannot remove an element from it. And we cannot replace an element with a new object, a new memory address reference. But we can certainly change the state of the object that's referenced in both positions of T. So yes, T is immutable, but the elements that T contained were not immutable. So in fact, T changed. From our perspective, the values that T contained changed. But T is immutable. Well, this is why we've got to be careful about what immutability really means, right? The tuple is immutable, but it can contain mutable elements. So do not confuse mutability with something that's completely frozen, that can never change, that it's not absolutely fixed. It can sometimes change. In the first example that we had, where we contained 3 integers, yes, that was completely frozen. It could never change, because not only was the tuple immutable, but it contained only immutable integers. Okay. So we just have to be careful here. So let's look at this. T equals 1, 2, 3. The tuple is immutable. So these are references to immutable objects, right, of type integer. So this will never change. However, in the second case that we looked at, tuple equals the list 1, 2, 3, 4. The tuple is still immutable. That hasn't changed. But those are references to mutable objects, and so we can change them. Right? So a very subtle point, but one to be careful with. So let's take a look at some code. Let's jump into some code and see all this in action and just make sure we understand it. Let's start with a list. So let's say we have my list equals 1, 2, 3. Okay? So this is a memory address. My list is an object. It's a list object, so we can actually do type of my list. It will tell us it's a list. We can also look at the memory address of my list, which is that. Now we can append an element to my list. We could do something like this, append 4. So now if we print my list out, we have 1, 2, 3, 4, but we'll notice that the ID, the memory address of my list, has not changed. This memory address here is the same that it was back there, right? So it hasn't changed. Now let me show you a different way of putting elements into the list. Let's say we have my list 1 is equal to 1, 2, 3, right? So it's that it has an address, my list 1. Okay, so this address here, which you'll notice is not the same as my list. Even though they contain the same values, they're not the same objects. Now I could do this. I could say my list underscore 1 is equal to my list underscore 1 plus, and I'm going to add that element, which is another list with one element 4. Okay, now we can look at what it is. It's now 1, 2, 3, 4. But you notice we didn't append here. What we did is we concatenated two objects. So what Python does, it first evaluates the right-hand side. So it first evaluated my list 1 plus list 4. And then it combined those two lists and returned a new object. And in fact, if we look at my list 1, we'll notice that its memory address is not the same as it used to be. That was changed. This was not modifying the internal state of my list 1, right? The .append method was modifying the internal state. So we'll get to those methods when we look at lists in detail. But for now, just be aware of that. Now, this is not just, the mutable objects is not just lists. We can say my dict equals, let's say we do a new dictionary. Now, you can create new dictionaries in a few ways. You can use the object constructor this way, or you can use a literal using these curly braces. I'm going to use dict. I like the keyword approach. So let's say key 1 equals 1, key 2 equals a. So now if we print out my dict, we'll see it contains these two key value pairs. Now we can look at the ID of my dict. Okay, so it's got this memory address. Now if we want to add another key in there, we can go and say key 3 equals, let's make it a floating point number. Okay, so now my dict is that. It's got these 3 keys, and the ID of my dict has not changed, right? It is still the same memory address. Okay, so now I want to take a look at that example that I showed you with tuples. So let's start with a tuple, 1, 2, 3. Okay. Now the ID of the tuple is something. It's again an object in memory, and every element of that collection, 1, 2, 3 in this case, are integers, and therefore they're also objects, and they happen to be immutable objects. So for example, I can look at the first element of the tuple. It gives us 1. I can look at the ID of the first element of the tuple, and this is where 1 is stored in memory. Okay, we can look at the ID of t and the second element in the tuple, and we get a different memory address, and so forth. So now let's go ahead and create a tuple that contains lists. So I'll just use literals. So let's say that the first element is 1, 2, and the second element is 3, 4. Okay? So now we can look at the ID of t. Okay? It has this memory address. Now we cannot add elements to the tuple. We can't remove elements, but we can certainly access the elements of the tuple, right? The first element is 1, 2. The second element is 3, 4. So we could take the first element and append, let's say 3. So now if we look at the tuple t, you'll notice that the first element has changed. Even though the tuple itself is immutable, the collection is immutable, the element was mutable. So we can modify the element itself. That's okay, but not the tuple. Okay? So that's really what I wanted to point out. It's a subtle distinction, but it's important to understand that just because you're dealing with an immutable object doesn't mean that the contents can't change, especially when it comes to collections. All right, so thanks for watching. I'll see you in the next video.